Welcome to Click Create Cognify, a space to explore how design, creativity, and consciousness connect. I'm your host, Reba, a UX design leader, strategist, and explorer of what happens when design meets intelligence. In today's episode, we're talking about something I believe every designer, product leader, and innovator needs to understand, and that's the difference between designing with AI and designing for AI systems. Because while the world races to use AI to make things faster, the real opportunity for us as designers is learning how to make things smarter. Let's start with a simple truth. AI has changed the nature of design forever, but not the way most people think. When we design with AI, we're using it as a tool. We prompt Midjourney, refine text with ChatGPT, or automate a workflow in Figma or even NAN. It's very powerful, and for now, it's still us in control. When we design for AI systems, we're stepping into a new frontier. We're shifting from designing the interface to designing the intelligence itself. This means designers' jobs now include things like defining how AI interprets data, deciding when it should act and when it should pause, creating different feedback loops for when it learns responsively, and shaping the emotional tone of the machine's behavior. We're shifting from more of a visual design space to behavioral orchestration. See, in this new era of AI, designing for AI is about how it learns from inputs, interprets data, and relays outputs. To truly design for AI, we have to understand it as a material. Painters have acrylics, sculptors have clay, and AI-driven UX now has artificial intelligence. What makes this material novel, however, unlike color, motion, or typography as materials, is that this material for itself thinks. And just like every material, it comes with unique properties that designers must learn to master. Properties for AI as a material are things like bias, where if our data is biased, then so is our output. Latency, which is the time between input and output, as well as things like outdated data, which can erode the trust of our users. You then have variance, which is that outputs change with each interaction, and sometimes even the same input will come with different outputs. You have opacity, so users don't often know why something has happened. That uncertainty erodes trust and confidence. We also have different modes of failure, so AI fails in different ways, often in a confident way, where users may not even know that it has actually failed and the data output is incorrect. I think it's pretty easy to see that then these properties shape the emotional and behavioral experience of using AI, and each in their own right present unique challenges that we have to design around. When we understand these properties, we can then design guardrails and signals that create confidence and trust rather than confusion. To do this, we as designers have to think in a different way. Think of it like this. A good designer now has to design for multiple different factors: what the AI learns from, what the AI says, how the AI says it, what the user can do about what the AI says, what the AI should say, what the AI should not say, and what happens if the AI fails. Tone, transparency, and timing are now part of the design system. For many designers, this is a mindset shift. We're not just designing features and flows anymore, we're designing the relative communication and relationships between human and machine intelligence. This is where, if you've been following me on LinkedIn, my 5-layer framework for designing for AI systems comes into play. Each layer represents a part of the AI experience that needs intentional design. The first layer is the input layer. This is where we're looking at what data goes in. We define not just the source, but the purpose, what signals are ethical, what context matters, etc. Some team actions that could be done around this are things like mapping data sources, things like user actions, sensors, context, APIs, and identifying which directly enhance the experience versus which are unnecessary. We can run an ethical data audit, categorizing data as essential, optional, or even intrusive. We can conduct data transparency workshops and prototype how to communicate what's collected and why. Example things being like consent screens, tooltips, and even explainer overlays. We can and should also collaborate with data scientists to define signal to intent mapping. Examples of things like what behaviors imply what goals. And just like we've done in traditional UX, we can create data journey maps, showing how raw signals flow through the experience. Additionally, we can prototype what-if scenarios. What happens if the system loses access to certain data types or fails altogether? Does it still perform, and if so, how well? If not, then what do we do? The second layer is processing. How does the system interpret that data? We co-design with data scientists, ensuring transparency and fairness, and we visualize what the AI sees. Different activities in this layer would be things like co-creating with data scientists a model visualization canvas, where we show what the input is, the transformation that's happening, the inference that's happening, and the output. We could design explainability moments, things like UI states or hover interactions, where users can understand why a result was generated. We could also conduct bias mapping sessions, where we're walking through real data examples to identify any potential unfair interpretations. We can also explore different ways to visualize patterns of confidence, things like badges or even contextual clues for how certain the AI is. We can also prototype AI reasoning overlays or other different components that reveal what features or factors influence a decision. An example of this would be something as simple as saying, "This is recommended to you because of XYZ." We can also include various roles in model testing to identify edge cases from different perspectives. Layer 3 is the output layer. How does intelligence manifest? Voice, text, visuals, or action? Designers craft the confidence level, language, and tone of each output. Different activities in this layer would be things like developing tone and confidence matrices, where we're mapping context to response style. So for example, healthcare might be more empathetic, whereas finance might be more authoritative. We could also prototype multi-output explorations, show users alternate interpretations or recommendations. We might conduct things like microcopy testing to measure how language affects users' trust. We could also look at error and uncertainty handling patterns. As an example, the system might come back with, "I'm not sure, but here's what I found." We could create AI persona guidelines, defining how the AI speaks or behaves and reacts across the interface depending on those personas. We can also run A/B tests on response framing, examples of that being showing exact confidence percentages versus a humanized confidence language. The fourth layer is the feedback layer. How does AI learn? We build feedback loops that empower users to teach the system. This also improves the trust factor as the transparency of what the system is learning becomes visible. Example activities in this layer are things like identifying teachable moments, where users can easily correct or rate the AI output. Or we might design lightweight feedback patterns, things like thumbs up, thumbs down, correction buttons, or improve this result prompts. We can even build feedback visibility into dashboards, showing users how their input affects the future results. Additionally, we might co-create with data teams feedback to model pipelines, defining which feedback signals get used for retraining. We can also test things like feedback fatigue, ensuring users aren't overwhelmed by requests for input. Additionally, we might look at areas to design trust-building cues. Example, your feedback helped refine this response for others. The fifth and final layer in the framework is control, and this is what power do users have. They should always have the ability to question, override, or opt out. Autonomy is a design feature. Activities in this layer might look like something of designing override patterns, or defining them, clear ways to revert or stop automated actions. We might create privacy control hubs, where users can view, modify, or delete data used by the AI. We could also explore explaining, editing, or opting out workflows, where users can question or even reject the AI suggestions. We might also look at, and should look at, human in the loop, where escalation flows come in, making sure that we route complex or risky cases to human support. We can prototype scenario-based autonomy tests and simulate what happens when AI fails or conflicts with user intent. We could even establish trust and control metrics and usability studies, how safe, in control, and respected users feel. When these 5 layers align, we have the foundations for creating ecosystems of intelligence. Let's ground this in reality with a few examples. So let's look at healthcare, for example. Imagine a digital health companion that personalizes insights from wearable data. It doesn't just tell you what's wrong, it learns how to communicate based on your anxiety levels and comprehension speed. In finance, we might have something like a predictive budgeting tool that explains its recommendations in plain language. Instead of saying you're overspending, it says something more along the lines of you're trending 20% above your typical weekend pattern. Would you like to set a boundary? This emotional intelligence is built into the AI. The common thread, no matter what industry you're in, is designing meaningful collaboration between human and machines through intentional analysis and understanding of data, ethics, possibility, and alignment. So, what all does this mean for design leaders? It means your next design system won't just include color tokens and typescales. It'll include behavioral tokens such as confidence levels, transparency types, and explanation patterns, etc. It means your design critiques will discuss ethics alongside usability, and your teams will include designers, data scientists, AI engineers, ethicists, all sitting at the same table. AI is creating an era where design is evolving. As AI grows more capable, human-centered design becomes more essential than ever. So ask yourself, when the next generation of users interacts with your product, will it feel intrusive or intelligent? That's where we, as designers, are playing an important role in the ethical advancement of designed intelligence in the age of AI. You've been listening to Click Create Cognify, the podcast where we explore how design, creativity, and consciousness connect. If this episode sparked new thoughts, share it with someone who's building the future, or connect with me on LinkedIn to discuss it further. From wherever you're listening, don't forget to subscribe or follow, because next week, we'll explore AI and UX versus UX for AI and how they play into the design of the future of intelligent experiences. Until then, keep clicking, keep creating, and keep cognifying.